We're going to code for a selection sort. How do selection sorts work? Well, they're going to locate the smallest element in an array, and so for here it'd be like 1, and it would exchange it with this very first value. And then it would do it again, looking for the next smallest, and then switching it with the next position. So this is how we would do it, and this is how we're going to code for it. We're going to need 2 loops, one for loop to go through the entire list, and then another for loop to repeatedly look through and see which is the smallest. So inside of here, we'll do that. We'll do for. We're going to have another for loop. So this is like the basic skeleton of it. We're also going to have an if statement that checks inside of here if we are going to be swapping. So that's what, or checking. This should check if one is bigger than the other. Outside of this is where we'll have our swap. So outside of this for loop, but still in the outer for loop, we are going to have the swap. So this is what it should look like. Now we know we want to run through our entire array. So we're going to do int a is equal to 0, and we want to run this as long as it's less than the size of our array. So to get the size, we're going to do int size, and we're going to set it equal to, wait for Replit to fill this out, help me out. We take the size of our array, and then we divide it by the size of, we're going to put our first element in here. That's how we get the size. So a is less than size, and we should have a size minus 1 though, because remember indexes are 1 smaller than the length, and we're going to have a plus plus. Now inside of here, it's going to be pretty interesting. What we're going to want to do is have a minimum value before this for loop. Int min is going to be equal to the index a. And the reason we want to do this is because we are first checking this index, and we're going to swap it for whatever minimum value it is. This is based on a because a increments, so we don't need to look at the indexes before it because we can assume that we've already sorted it with this inner for loop. So in this inner for loop, we are going to have an int b, and we're going to want to set it equal to a plus 1 because we already have our minimum value here, so we can look at the next value. After we do this, we want to run this as long as our b is less than our size, and we'll do size minus 1. That should get our index, and then we'll have b plus plus. And that's pretty much going to be it. Inside of our if statement, we are going to want to do the comparison. If the minimum value, so our ARR with the minimum value, if it is greater, so we'll come on this side, if it's greater than our current ARRB being this next value, then we're going to want to put the new minimum value into min. So we'll say min is equal to the index b. And this is only if these two are not in order. So this one is smaller than this one, we need to replace this as the smallest to be our new b. And then we are going to repeatedly do this. Once we're done at the end, we'll finish our for loop, and we're going to swap. We're going to want to swap the elements at our new minimum, so ARR at the new minimum, and swap it with the ARR at our current value, which we're looking at, which is going to be this A. And that's pretty much going to be the swap complete. Let's try to print this out and see what we get. For int A, we'll run this as like a for each loop, see out, we print out our A, and then we print out a space, and then we can end this line. This looks pretty good here. Let's try to run this and see what we get. And I do have an issue at the back here, and the reason for this has to deal with the inner for loop. I made a mistake in here, and it's actually going to be inside the header. Taking 1 off it is not necessary, so we can run this, and you'll see it's going to print out the correct thing. The reason why it's not necessary is because if you look ahead of it, we have this a plus 1. So what we're doing in actuality is, it's great that we have the size minus 1 here. This is perfect. This is what we want because index is 1 less than our length, but we are incrementing our index here. We're starting at 1 ahead. So this could be size minus 1 to comply with the indexes, but since we have this plus 1 here, we're also going to need a plus 1 like this if we were to kind of even it out. So you can either have nothing or you can have this. It doesn't really matter. This kind of shows you what's happening, so I'll leave it like this. You can see that we have a correct run here. That's going to be it for a selection sort. If you want to see other sorting algorithms or more C++ videos, check out the playlist below the like button. And if you want any explanation further on this material, leave a comment below and ask.